So the first derivative is 2 e to the x over e to the x plus 2 squared. You can say that 2 is not such a big deal. You can leave it in. Yep, you could. So the second derivative, 2 e to the x plus 2, everything to the fourth power. The top function prime, e to the x, times the denominator, minus the top, times the denominator prime. Can anyone differentiate for us e to the x plus 2 squared? And I'll put it here. Please try. I need to differentiate the denominator and put it here. What do I write? Anyone, please? Can anyone help differentiating e to the x plus 2 squared?
We'd have to bring down the 2.
Absolutely. 2 comes down, times e to the x plus 2 to 2 minus 1, times the inner function prime.
E to the x.
E to the x. And I'm going to say, please do not distribute. Do not distribute. Please. What we are going to do is factor. Factor. So 2 is outside, waiting patiently. Has nothing else to do. I have an e to the x in this and an e to the x in this. So e to the x is a common factor to both. Which, if you want, it's this. But also, there is another common factor, which is e to the x plus 2. So I have e to the x plus 2. Good. E to the x is out. One of these two is out, but still one is left in. E to the x is out. E to the x plus 2 is out, but I still have negative 2 e to the x over e to the x plus 2 to the fourth. So let's do this one more time just to make sure it's clear. Top function prime, e to the x, times the denominator minus the top, times the denominator prime, 2, e to the x plus 2 to 2 minus 1, so this is 1, times the inner function prime, which is e to the x. We took out e to the x. We took out 1 of e to the x plus 2, so that's why there is 1 left in. This is out. This is out. So I have negative 2 e to the x. I will, of course, simplify one of these. That's the only way I can do it. And continue. Well, good. So 2 is outside, e to the x still in there. Negative 2 e to the x plus e to the x, negative e to the x plus 2. E to the x plus 2 to the third power. You can pull out a negative sign. 2 e to the x minus 2 over e to the x plus 2 to the third power. My goodness, a lot of calculations here. So at this point, I know it's either 0 or undefined. Not possible, because so is the function, and this is never undefined, actually. So it can be 0, not when 2 is 0, not when e to the x is 0, but only when e to the x minus 2 is 0, or e to the x equals 2. How do I solve such an exponential? equation.
You can bring it back down into
By
natural
applying natural log to both sides. Excellent. So we have x equals natural log 2, which is a positive number because it's above 1. So natural log 2, 0.7 approximately. Five pages ago, right here, 0.7 and 0 for the second derivative. Now, let's analyze and see what happens here. I have to study the sign of this, to put the sign left and right. I refuse to study the sign of this because it's always positive. I refuse to study the sign of this because it's always positive. So what I'm studying the sign for is negative e to the x plus 2. So I will put this in the graphing calculator, just that. I don't care for anything else. So in y equals, clear anything else, and just put in 2 minus e to the x. And all I want to do is plug in a number to the left of 0.7, like -5, and a number to the right of 0.7, like 15. Ah, excellent. So to the left of 0.7 is positive. Which means it holds water. And afterwards is negative, which means it does not. I have to put in the function 0.7 because I need this point. I need the y value. So in the graphing calculator, again, I will put in e to the x. And divide by, don't forget parentheses for the denominator, e to the x plus 2. And I only need one number. The number is for 0.7. 8.1 approximately. Perfect. Since there are no max min, but I did find 0.7 comma 8.1. What type of point is this? I need to write something next to it or underneath. So what point is 0.7 comma 8.1? Always remember it comes from the second derivative. What can it be? The second derivative is 0 and it changes sign at that point. So what could it be? 0.7 comma 8.1.
the inflection point.
Indeed, that's all it is. It's an IP. Now if I ask when is the function, or what is the interval for which the function is concave upward, what will you say? The function is concave upward on which interval? Can anyone tell us, please? So it's concave upward?
It's concave up until that inflection point.
Yes, from negative infinity
to 0.7.
Excellent. And it's concave downward from?
0.7 to infinity.
That's it. Okay. Of course, we're going to practice this table in a minute with a gibberish, something that I call gibberish. You know what I mean. And we're also going to graph when we're going to use it when we're going to graph, which is the next step. Good. So now we want to choose a gibberish and move on. Who would like to choose the gibberish? From 36 all the way through 41.
Can we do 40?
Which one? 40? 40?
Yes.
Okay, perfect.
Yeah, 40.
Perfect. It will take me 5 minutes to copy it. Sorry about that. And keep an eye on what I'm writing because, as you know, the computer is so far away from me, or I can copy it from the book. I have the book here. So f prime of 0 is 0 and equals f prime of 4. Then we have f prime of x is 1 if x is less than -1. F prime of x is greater than 0 for 0, x, and 2. F prime of x is less than 0 if -1, x, and 2, union, that's what the OR is, union, 2 less than x less than 4, union greater than 4, x greater than 4. Okay. Then we are told that limit as x approaches 2 from the left. 2 from the left of f prime. 2 from the left of f prime. Very possible. We'll discuss that in a minute. So limit as x approaches 2 from the right of f prime of x. The second derivative is greater than 0 if -1 less than x less than 2, union 2 less than x less than 4. Okay. And finally, the second derivative is less than 0 if x is greater than 4. Okay. Sorry about that. It took me a while to copy everything. Of course, this means nothing. I don't even know where to start, but it will be very clear and very soon. I have no idea where to start, but I'll start somewhere. So -infinity to infinity. Okay. So I'm going to look at these numbers. So let's see what numbers we have. We have -1. We have 2. We have 4. That's pretty much it. -1, 2, and 4. Fine. -1, 2, and 4. They're telling us that the second derivative is positive for x between -1 and 2, and 2 and 4. I hope I copied everything correctly. Let's take a look just to make sure. The second derivative, positive from or 2 and 4, okay. And negative beyond 4, okay. So this is done. And this is done. So the second derivative is positive between -1 and 2. They're not telling us anything here. It's up to us so far. Maybe there is some indication later on. But right now they're only telling us between -1 and 2 and 2 and 4 it's positive. And negative between 4 and infinity. So this is clearly opening upward. And this is clearly opening downward. And these two are done. Okay, I'm going to look now at the first derivative. The first derivative is 0, so I also have 0 here. The first derivative of 0 is 0, and so is the first derivative at 4. Obviously, these are what? 0 and 4 are what? If the first derivative is 0, at 0 and 4, what are these? Critical numbers. They're not points, but you're right, we can call them points. Okay, so this is done, this is done, this is done. Okay, here. F prime of x is 1 for any x less than negative 1. For any x less than negative 1, the first derivative is 1. Okay? Which means if the slope is 1, that piece must be a straight line, because only a straight line has a constant slope. Good. So this is done. F prime of x is greater than 0 between 0 and 2. Between 0 and 2 is positive. This is done. It's less than 0 for negative 1 to 2. Let's take a look again. It's negative 1, 0 union to 4. Now it makes sense. Sorry about that. Good. So between negative 1 and 0, the function, the derivative is negative. And also between 2 and 4. And also to the right of 4. All negative. Double checking one more time for this part. So it's negative between negative 1 and 0, yes. Negative between 2 and 4, yes. And greater than 4, okay, fine. So all these are done. And now the last step, I have to discuss this. But everything else is already in the table. So before we put that in, obviously here the function has to be decreasing. Here the function must be increasing. And this point must be a relative min. Here, increasing and then decreasing, so this point must be a relative max. Here at 4, something happens because it changes concavity, so this point must be an IP. Here, the function must be a linear function, linear. How do I know? Because only a linear function has a constant slope. So I identify everything else. Now I need this. They say that the limit of the derivative as x approaches 2 from the left is infinity. What does that mean? And to the right is negative infinity. So
if it's approaching infinity would mean that there's no max or min.
Yes. But what it says is that the limit of the rate of change as x approaches 2 from the left of the rate of change is infinity. And the limit as x approaches 2 from the right, the limit of the rate of change is negative infinity. So something special happens at 2. I jumped into the conclusion without putting the last piece. So if the first derivative is positive, it means that, but the limit is infinity, it means that there is a vertical asymptote going to and increasing. And on the other side, right, on the other side, the function is decreasing, and the limit is negative infinity. So we'll see in a moment how we address that. So let's put the rest. So because of this new information that we have in there, I have to remove the relative max, because it appears that is a asymptote there. Okay, so let's take it from left to right. It's a very interesting problem. So this is linear, that's why there is no information about concavity. So linear has no concavity. In other words, the derivative, the second derivative of a linear function is 0. But we don't really need this. So at -1, till it gets to -1, the function is linear and it has a slope of 1. Okay? And then it starts decreasing. Slope of 1, linear. It gets to this point, whatever the point is. Allow me to change